This is the QF-RD72 cycling relay module. I hope this video will help other amateurs like me decide if this is the product they need and answer questions about how to make it work. This video has 3 sections. 1. An overview of the product describing features and specifications. 2. A wiring diagram for both the relay and the trigger circuit. And 3. A guide on how to use the switches and potentiometers to control the on and off times. Section 1. An overview. This 12-volt DC module is a simple circuit designed to control an external device. It can be used to turn the device on for a given length of time and off for a given length of time and cycle through the on-off states until stopped by the user. The minimum on and off time is about 0.2 of a second. The maximum on-off time is about 16 hours and 40 minutes. The times are approximate as this module has no way of programming precise on or off durations. The switching circuit is supplied by this relay and these 3 terminals. When the module is powered, the relay is in the off state, the center common terminal being connected to this normally closed terminal. When the module is triggered by a user-supplied switch, the relay common terminal connects to the normally open terminal for the given on time, then switches back to the off state for the given off time, and cycles through those states endlessly. The process can be stopped by the user at any time with a press of the same trigger switch. The user-supplied trigger switch can be a momentary contact push button or a high-level trigger signal between 2 and 30 volts. The relay is optimistically rated at 10 amps. Section 2. A wiring guide. This module is powered by 12 volts of direct current, the positive lead connected here and the negative lead here. The switching circuit is provided by this relay and these 3 terminals. I have my test stand wired like this with a power supply and 2 indicator lamps. The red light connected to the off or normally closed terminal and the green light connected to the on or normally open terminal. I've opted for a simple momentary contact push button connected to these 2 terminals. This push button is used to start the cycling between the on-off states after the module is powered. A second push of this button will immediately put the relay in the off state and stop the cycling. If you choose to use an external device to trigger this module to start, a high-level trigger of between 2 and 30 volts applied to the same 2 terminals will do the trick. The first trigger starting the module, the second trigger stopping the module. A third triggering option is to simply short these 2 terminals with a jumper. This will cause the module to immediately start an infinite cycle between the on and off times when initially powered. Section 3. Configuring the on and off times. Configuring the on and off times can be done regardless of whether the module is powered. The on-off times are configured by using these 6 controls. These 3 control the on time, and these 3 control the off time. Because the controls are identical, we'll look at configuring the on time only. First, if you see anything looking like this online, disregard it. It is completely inaccurate. These 2 switches will allow us to select the duration of time we're working with. With the right-hand switch in the down position, we're working with seconds. If it's in the up position, we're working with minutes. The left-hand switch will allow us to work with hundreds of seconds or minutes, or thousands of seconds or minutes. Let's say we want an on time of 45 minutes. Doing a little math, we can see that 45 minutes is 2,700 seconds. Far more than the maximum of 1,000 seconds available to us. We're going to have to work with minutes. So let's flip the right-hand switch up to the minutes position. Next, we'll look at the left-hand switch. Our options here are 0 to 100 minutes or 0 to 1,000 minutes. Our desired 45-minute on time will fit nicely into the 0 to 100-minute window. Let's put the left-hand switch in the 0 to 100 down position. Now we're going to use the potentiometer above the switches to dial in our on timer to 45 minutes. The potentiometer swings through an arc of about 270 degrees from here to here. We know that if we put the potentiometer in the exact center of the arc, we'll be at around half our maximum of 100 minutes, or about 50 minutes of on time. Dialing it down just a bit further will get us closer to 45 minutes. How do we know when we're there? We don't. Not unless we connect a clock to the relay and check it every 45 minutes or so, adjusting the potentiometer each time. If you need split-second accuracy, this is not your product. Let's take a closer look at the potentiometer and do some math. We'll assume the potentiometer has a control arc of 270 degrees. Here's what that means. If you're working with hundreds of seconds, each single degree you turn the dial is equal to about 0.4 of a second. If you're working with thousands of seconds, each single degree you turn the dial is equal to just under 4 seconds. If you're working with hundreds of minutes, each single degree you turn the dial is equal to a little more than 22 seconds. And if you're working with thousands of minutes, each single degree you turn the dial is equal to more than 3.5 minutes. As you can see, the larger the time you're working with, the lower the resolution of control accuracy. At this point, use the off timer to configure your relay off time. When you're done, power on the module. The relay will always start in the off state, waiting for your trigger. Once triggered, the relay will immediately switch on for the on time, off for the off time, and cycle between the on-off states continuously. It will only stop when it receives a second trigger or is powered off. In either case, the relay will always stop in the off state. I hope this video will help you determine if this product will work for your project and will be a useful reference for you when it's time to wire it up and configure your on and off times.